Namaste friends, myself Maruti Kulkarni. Welcome to the Electrical and Instrumentation Engineering YouTube channel. In this video, I will explain you the basic details about the transformer nameplate. The parameters mentioned in the transformer nameplate, I will explain you in detail. Please watch the video till the end. We will begin this video with the transformer nameplate details. The photo I have enclosed on the screen, which has been taken from the transformer installed in my site. See in the image that we are going to discuss about the OLTC, vector diagram, vector group, voltage levels, basic insulation level, CT details, OLTC tab details and position indicators, and what are the transformer specification, everything is mentioned in the below of the image. You can see we are going to discuss about all these parameters in this video. Please keep watching this video. Here on the screen, the vector group DYN11. So first we will learn about what is the vector group. So vector group defines how HV and LV circuits are connected in three-phase transformer. In every transformer there are two circuits, one HV circuit and an LV circuit. The circuit may be step up or step down from other end, from one end to other end. So how they are related to each other. With the vector group only we can identify what type of circuit it is, either DYN11 or DY11, and many type of vector groups are there. We are going to discuss about the types of vector groups. See, I have mentioned the four types of vector group here. The 0 degree phase displacement, that minus 30 degree phase displacement, plus 30 degree phase displacement, and last one 180 degree phase displacement. I have shown the plots of all the vector group details, which we are going to discuss in the next slide. Just keep watching. Let's discuss with the vector group. Here the vector group is DYN11. So let's understand what is DYN11. First letter is D. The D means the primary side of the transformer is delta connected. Please see the vector diagram here. The primary side which is connected is a delta connected. Okay. It's a secondary side. What is the second and third letter denotes? It's a YN. It's a small letter YN. The small letter YN means the secondary side of the transformer is star connected, which is shown in the vector diagram of the transformer specification. And the neutral brought out to the system, that's why the small n is also mentioned with a small y. Okay. 4 digit. The 4 digit is 11, which represents the phase shift. It is corresponds to the 11 hour in a clock, which is 30 degree phase shift. See, I have enclosed all the 4 images here, which is 30 degree phase shift, minus 30 degree phase shift, and a 180 degree phase shift, and 0 degree phase shift. By seeing the image, the 11 hour which is represent, the secondary voltage leads the primary voltage by 30 degree. That is called the DYN11 system. Here we will discuss about the basic insulation level. Impulse voltage. Impulse voltage means the maximum voltage test. Okay. In this, the purpose of this test, what is the purpose of doing impulse voltage test? The purpose of impulse voltage test is to secure the transformer insulation from over voltages, which may occur during lightning. During the lightning period, we will get over voltage to the system and it may damage our transformer. That's the purpose of doing impulse voltage test. See the image I have enclosed here, the transmission line, which are at the higher side height. In this higher side height, the transmission lines are more vulnerable to the lightning. When lightning strikes, this may develop an impulse voltage which is almost 3 to 4 times of the applied voltage. In our system, if we apply the 11 kV to the input side, during the lightning period, it may go up to the 45 to 50 kV to the transformer primary side. So to secure the transformer insulation from this damage, we will do the impulse voltage during the manufacturing time. So this condition may damage insulation of the transformer. So by carrying out the impulse voltage test, the manufacturer and customer can ensure that insulation can be protected at voltages level. So here it is mentioned is the kVp. What is the kVp? kVp in electrical term is a peak kilo voltage. That is 75. This transformer tested at the 75 kVp impulse voltage. In continuing with the basic insulation level, now the term is PF voltage. First we will understand full form of PF voltage. The full form of PF voltage is power frequency voltage. Now the next question arises, what is the PF, power frequency voltage? Here I have mentioned the definition. In basic insulation level, power frequency voltage means injecting of RMS value of voltage in kilovolts for the duration of 1 minute. Either you apply to the voltage to primary side or secondary side, HV side or LV side. In our specification, the HV side PF voltage applied is 28 kV RMS, which means They have applied test the insulation of HV winding by applying 28 kV RMS value for a duration of 1 minute. And in LV side, the specification mentioned that 3 kV RMS has been applied to test the insulation of LV winding for the duration of 1 minute. In this duration, applying the HV side voltage and LV side voltage gives us the basic insulation level. Now we will discuss about the vector diagram. Please look into the figure which is mentioned in the transformer specification. In the transformer, we are having two sides, that is an HV side and LV side. In HV side, there are three phases which is named as a 1U, 1V and 1W. In LV side also, we are having a three phases which are mentioned as 2U, 2V and 2W. And the neutral has brought out to the system as per DYN11. What it means DYN11? DYN11 means LV side of the U phase vector named as a 2U leads the HV side U, that is 1U, by 30 degree phase displacement. It is applicable to the same phases, other phases also. That is LV side V phase vector 2V leads the HV side V phase vector 1V by 30 degree phase shift. And the LV is same applicable to the W phase also. LV side W phase vector 2W leads the HV side W phase vector 1W by 30 degree phase shift. Let's see transformer specification. We will discuss about the point WTI CT, which is mentioned as a 2670 by 5 amps class 5 and the burden is 20 VA. So what is WTI CT? It's the winding temperature indicator current transformer. The purpose of using this winding temperature indicator current transformer is to alarm and trip the circuit breaker. It is the indirect method to measure the winding temperature since it is dangerous to place the sensor near to the winding due to the high voltage at the primary and secondary side. The winding is one and only the component with the highest temperature within the transformer. As the load rises, the transformer temperature will increase. So, to measure the temperature, we will use the CT secondary current. So, we will discuss about the set points. General set point to give an alarm at 80 degrees Celsius and general set point to give a trip command to the breaker is at 90 degrees Celsius. In this specification, the CT ratio we have selected is 2670 by 5 amp. Why 2670 is selected? Because the transformer full load current at the secondary side is 2670 amps as mentioned in the transformer specification. So when the transformer reaches the full load current, the current to the secondary side of the CT will be the 5 amps. Hence we can think that the temperature has risen 100%. So and the class 5 is the accuracy of the CT and 20 VA is the burden of the CT. Burden means the maximum load that can be applied to the CT secondary, which is called the CT burden. Please look into the diagram which I have enclosed in the sheet, which will give you the brief idea about the WTI CT and its indirect method to measure the temperature of the winding inside the transformer. After completion of the WTI CT, now we will discuss about the NCT, which is mentioned in transformer specification. The NCT is mentioned in the transformer specification is as 3001 amps secondary side. And the class is PS and new voltage greater than or equal to 30 and the magnitude of the current is at 30 milliamps at VK by 2. Okay. First we will learn what is NCT. NCT, the full form of NCT is the neutral current transformer. Where is the neutral? Neutral is coming only in the star winding of the transformer. Hence the neutral current transformer is placed between the neutral point and the neutral earth point of the transformer. This NCT is used to measure the flow of current through the neutral. When the current will flow in the neutral, when there is an abnormal in the transformer, okay, or it's winding or it's an earth fault, the secondary side of the neutral current is connected to the earth fault relay to protect the system from earth fault. Please understand, once more I am repeating this, the secondary side of the neutral current transformer is connected to the earth fault relay to protect the system from the transformer. Please see the image which I have enclosed. The secondary side of the NCT is connected to the relay, which is the earth fault relay. It may be REF relay or standby earth fault relay, any earth fault relay. The fault, when there is a fault in the system, the current will flow through the neutral only, and when it is unbalanced also the current will flow in the neutral. In this specification, the neutral current transformer is 3000, the primary side of the current is 3000 amps and the secondary current is 1 amps. And what is the class means the special the class special is a PS. PS means the special protection class, which is the type of the CT. And VK is the knee voltage, that is the greater than or equal to 30 volts. And the I magnitude is the 30 milliamps at knee voltage, half of the knee voltage. In continuing with the NCT details, the neutral current transformer, here in the transformer specification, we can see that the primary current of the neutral current transformer is 3000 amps and the secondary current of the current transformer is 1 amps and the class is special protection, that is called a PSR. Okay, let's start with the concept with the following example. Here we can calculate how the neutral current can be calculated. I have given you the formula from which we can calculate the neutral current. Here see the line current, IN is the line current and IR is the R phase current and IY is the Y phase current and IB is the B phase current. I have given you the formula how neutral current can be calculated. Let's assume that R phase is having a earth fault and current in the R phase will be the 0. Okay, at that time if you calculate using this formula and calculating this formula, you will get the derive that line neutral current will be the 2200 amps. And if we fix our set point at a 0.1 amps of the CT secondary ratio in earth fault relay should operate instantaneously on trip breaker. Since the relay received approximately 0.7 amps from NCT, 2200 amps for 3000 amps means it's 0.7 amps in the secondary of the current transformer. You can check the drawing I have mentioned below the screen, from which how earth fault relay will be calculated and how 2200 amps will be circulated through secondary of the current transformer to relay, and relay will operate instantly and trip the breaker. Now our topic is OLTC, which stands for on-load tap changer, which means we can change the tap of the transformer and change the secondary voltage of the transformer by changing the tap on low. Let's see the theoretical explanation here. The purpose of operating the on-load tap changer is to increase or decrease the turns so that the transformer acts as a step up or step down transformer. In our specification, it is a step down transformer. We can see the chart specification described in the OLTC indicator position tappings connected, how HV and LV volts. In this on-load tap changer, we can observe there are 17 positions and 16 steps. On-load tap changer advantage is we can operate the mechanism during the load only, that is without interrupting the power to the transformer. Practically, it is very useful in controlling the transformer secondary output voltage. On-load tap changer can be operated through manually or using the automatic tap changer panel. Automatic tap changer panel will operate itself as per the reading HV voltage to maintain LV voltage. For example, if our tap position at that 8 and our HV voltage is 11 kV, obviously LV voltage will be near to 470 volts, which is harmful to the devices. If the breaker is using over voltage protection, the set point is at 460 volt, then the breaker will give command to the trip coil and will get trip instantaneously from over voltage relay protection. Then by reducing the tap changer position to 5, the voltage of the secondary side will be changed to 433 volts. In the previous slide, we have learnt about the OLTC and its purposes with an example. In this slide, we will question that why tap changing is done at the HV siding only. You see in the diagram, the HV winding is wound outside the LV winding, so the manufacturer will get easier to get the tapping connection of the tap changer. Also, the HV siding winding current are very lower, so that the leads, contact and other equipments required for the tap changer can be used very smaller. Please look into the diagram very closely, how HV winding is wound outside the LV winding. In our specification, now we will learn about the type of cooling, which is on-and. On-and stands for the oil natural, air natural. Look into the image enclosed in the slide. So inside the transformer, the electricity will flow. The flow of electricity will create the heat. The heat is transferred to the transformer oil due to the conduction. Now the heated oil will rise the oil level because it becomes lighter. As the heated oil rises, the cooler oil will take place at the bottom. This movement of oil happens naturally, hence this is called the oil natural. To minimize this heat, we need the air around the transformer. The heat is taken away from the ambient temperature, hence it is called the air natural. That's why we call the cooling type of this transformer is mentioned in the nameplate is on-and cooling type. The efficiency of the cooling system depends on the following factors. Please look into the factors I have mentioned here. The temperature of the ambient air and the surface area of the transformer. To increase the surface area, external fitting that is called a radiator is fitted onto the transformer tank. This method of cooling of the transformer is suited up to the capacity 5 MVA only. Now we will move into the next topic, rating. Here in the specification, the rating of the transformer is 2 MVA, that is 2000 kVA. The rating of the transformer is always mentioned in the VA only. So there are two reasons why the rating of the transformer is mentioned in VA only. The reason number 1, losses inside the transformer. Reason number 2, transformer support both the loads, that is inductive as well as capacitive. We will go into the detail of the each reason. The first reason, the losses inside the transformer. Well, we all know that there are two types of losses in the transformer. One is iron loss, another is copper loss. Iron loss depends on the voltage and the copper loss depends on the current. Hence, the total loss in the transformers, what we call it as heat loss, which is depend on the volt ampere. Hence, this is the one of the reason the rating of the transformer is in VA. And the second reason, the transformer support both loads, that is inductive load as well as capacity load. At the time of designing the transformer, the manufacturer do not know which type of load you are connected to the transformer. The customer can connect either inductive load or capacitor and inductive as well as capacitive load also. As we know the expression that the apparent power is equal to the inductive power as well as reactive power. So watt plus kV VAR is equal to VA. This is the reason why transformer rating is always in VA, not in watts. Now the next section is voltage ratio. The voltage ratio of the transformer mentioned in the nameplate is 11 kV by 433 volts, which is HV side voltage is 11 kV and the LV side voltage is 433 volts. By knowing this voltage ratio, we can understand this transformer is a step down voltage because it transfers voltage from 11 kV to 433 volts. And the second one is line current. HV side line current is 104.07 amps and LV side mentioned as a 2666.75 amps. It means that whenever the transformer is in full load, HV side draw 104 amps and the LV side draw 2666 amps current. And the phases mentioned here are 3. It means that HV side having a 3 phases, which is mentioned as 1U, 1V and 1W in the vector diagram, and the LV side having a 3 phases, 2U, 2V and 2W, which is also mentioned in the vector diagram. You can observe the vector diagram here, which is represented the phases. In this slide, we will understand what is impedance voltage. Before understanding impedance voltage, first we will learn what is impedance. We all know there are 3 types of load: resistive load, capacitive load and inductive load. We will go to the detail with one by one. What is the resistive load? The resistive load do not store or release the energy when the current is flowing through the coil, which is straightforward. The resistive load which are using in our households, that means the heaters and the bulbs, these do not store or release energy when the current is passing through them. Second one is inductive load. Inductive load store or release energy in the form of magnetic field during the flow of current through the coil. The example of inductive load is the 3-phase induction motor. And the capacitive load. The third one is capacitive load, which stores or release energy in the form of electric field during the flow of current through the coil. The example of the capacitive load is the capacitor or series of capacitors I have displayed in the image. In continuing with the impedance voltage term, in this slide, we will see there are 3 types of load, that is resistive load, inductive load and capacitive load. The impedance means the combination of all 3 loads, that is resistive load plus inductive load plus capacitive load. In terms, we can say that when circuit experiences all these loads to oppose the flow of electrons through them, this is called impedance. Impedance is denoted by Z and measured in ohms. The impedance comes only when you are working under AC current or AC voltage. When in DC voltage, only resistor will come. Please see in the specification, impedance voltage is mentioned as a 6.40%. So what it means, when the transformer is connected to the many types of load which I have shown in the figure. The transformer is connected to the resistive load, the transformer is connected to the inductive load as well as the capacitive load. When we apply, what is 6.40%? When we apply full load to the transformer and the circuit experiences all types of loads, then the voltage in the secondary side will drop 6.40%. Let's understand this concept with an example which I have mentioned below. See, when the transformer is under no load, the voltage at the secondary side is 433 volts, as we know in the transformer nameplate. Okay. Next, that when we apply transformer to full load, that means resistive load, inductive load, capacitive, whatever the load we apply, and the transformer comes into the full load, The voltage in the secondary side is 405 volts, which is 60.40% less than the actual voltage. The actual voltage is 433 volts, but the voltage drop when the transformer is full load is 405 volts. The drop of voltage is 6.40%. This is called the impedance voltage, which is mentioned in 6 percentage. This is also called as a percentage impedance as well. Now moving to the final parameters, that is frequency, core and winding details, or transformer oil details. Here in the transformer, the frequency is mentioned as a 50 Hz, and the core and winding weight is 2500 kg, which is approximately, and the weight of the transformer oil is 1490 kgs, and the oil quantity of the transformer is 1670 liters. Thank you for watching my video. If you have any queries, please type it on the comment box. I will try to reply everyone. Thank you very much.